Okay, this is section 11.4, areas of composite figures. Composite figures can be separated into regions that are basic figures. So I don't know if you've heard about tangrams before, but basically, as you can tell, it looks like a rabbit, but every part of that is a different kind of a polygon. And while ours aren't going to be so interesting looking or as maybe diverse as that, that's what we're diving into for this next section. All right, this is just a one video section. It's not notes or information and examples. It's just all into one. That's your information basically. And this is section 11.4. All right. Basically, when you're working with composite figures, you're either going to be adding the parts or you're going to be subtracting out a piece or parts. So you're going to find the area of one whole piece and add on other areas. You're going to find the area of one whole piece and then subtract some other areas. So kind of your goal here is to add or subtract the parts. All right, so if you look at this picture, you can tell you have like a rectangle. Like here, I would find the area of the rectangle, find the area of these two half circles, which, by the way, is a full circle, and then find your area, oopsie, of this triangle, and then, of course, add it all together. That'd personally be my plan for this. All right, so let's start with the rectangle first of all. So rectangle plus circle, and I'm going to call it just a circle instead of two half circles, plus the triangle. So now I have to put all of my areas together. So the area of the rectangle, 32 by 16, plus the area of the circle. The circle is pi r squared. The radius, okay, because if I move, I think actually I have this so that I can move it. No, I didn't. All right, so if I take my radius, it's going to be 8. Oh dear. My radius is 8. So I'm going to have pi times 8 squared. Plus my triangle, which is 1/2 base times height. There we go. Once again. Okay, 1/2. The base of this triangle, I'm going to go like this. Call this the base, which is 15. And then I have the height, which is this dotted line here. And that height is right here. It corresponds to 32 feet. So then it's just a matter of doing the math. 32 times 16 is 512. Then I'm going to take 64 times pi, and once again, the pi button. And we're going to put a lot of decimal places because we round to the end. And then 1/2 times 15 times 32 is 240. All right, and I can add all those things together. And I'm going to get 953.1, and they should be feet squared. I'm still working with areas, so it'll be feet squared. Next problem. This, I have a rectangle. I find the area of the large rectangle, and I'm going to subtract out the smaller rectangle inside. So the big rectangle, I'm going to take this length times the width, and I have 25 and 25 and 20. So that's going to be 25, 20, and 25. That's a total of 70. Then I do the same thing this way. I've got 25 from here to here. How do I know that? From this little piece. And then I have 100 from here to here. And I'm going to have 25 feet around on the other side. I know it doesn't look like it there, but I've got 25 all the way around this. So this would be 150 for the entire length. So 150 times 70 is going to give me the 10,500. Then I'm going to subtract the area of this small rose garden. The rose garden is 20 feet by 100 feet. We take 20 by 100. So 10,500 minus 2,000 is going to give me the leftover area for the lawn, which is 8,500. The label you should have is feet squared. Okay, third one. Very similar to our first figure, kind of the same idea. Oh, and of course, this is where I thought I did something like this. Oh yeah, this is my full circle over there. So that's part of the reason why I can put this together. All right, area, rectangle plus circle. The rectangle is 14 by 8. 14 and 8. My circle is still going to be a pi r squared. My radius is half of that 8, which is 4. So I'm going to have pi radius of 4 squared. So I have 112. 14 times 8 is 112 plus 16 pi. And you can calculate that on your calculator, and you're going to get 162.3. And I do not have a label on this one. It would be, if you really had to, units squared. Make sure you're squaring the unit and not the number. Okay, next example. This is a problem that you need to turn in to me at the beginning of class. You have to do it on a separate sheet of paper, so when I ask for it, you turn it in. You will not get credit unless you have the work, so be very thorough about showing your work. I'll give you kind of a general guideline here. You have a rectangle, and you're going to subtract out, you're not going to subtract out a circle, you're going to subtract out half of the circle, because you only have half of the circle there. All right, so you're going to show me your steps on that, give me your answer, and that would need to be turned in to me at the beginning of class when I call for it. And if you are gone for the day, you better turn it in the next day to me or the box. All right, and that is it for today's lesson. 8 minutes, not bad.